Good evening. This is Elvis Medam representing on branch and bound algorithm. So we are going to look at three strategies here, which is the Fifo method and the Lifo method, also the least cost search method. I'm here with.
Kumtai Francois.
So let's go to the introduction of our work.
Introduction. Branch and bar refers to all state space search methods in which all children of the E node are generated before any other live node becomes the E node. Branch
Wait.
and bar.
Let's just go.
The live node is not that has been generated, but whose children have not yet been generated. E node is live node whose children are currently being explored. In other words, an E node is a node currently being expanded. D node is generated, a node that is not be expanded or explored any further. All children of the D node have already been expanded. Here, we will use three types of shared strategies. First one, FIFO means first in, first out. LIFO means last in, first out. And the last one, least cost search.
So we are going to talk on the first in, first out bridge and bound search, which in real life example goes as follows. When you are going maybe to a market to buy things, let's say stuffs, you need to stand on the line. Or you are in the market, you want to buy meat, you need to stand in a line in which when you count first, the person will step first and then you leave first. That's the meaning of first in, first out. And the type of data structure that we are going to use here is a queue. Initially, the queue is empty. So we assume that there is no person there, there is no element there. So, but our target here is 12. So, we want to get 12 as our answer, as you can see. So, the E note, as you assign an E note as 1, as we earlier discussed, you have seen what is an E note is. An E note is a live node whose children are expanded. So, we need to get the expanded node of E note 1, which are 2, 3, 4. First in, first out. So the first element there is 2, and the second is 3, 4. So they'll take their respective positions. Now we will delete an element from Q. So that's 2 because it's the first that was in our Q. Next, generate the children of 2 and place in that. So let's go back to our diagram or picture. We'll see that the children of 2 here generate to 5 and 6. So that's why it's our children. So now we'll place in the queue as follows. This is it. We have now 3, 4, 5, and 6. So proceed. So next we'll delay. We'll keep on repeating this process until we'll get to our desired branch. So which is 12. So we'll check 5 now. The children of we'll check now our E node now will assign to 5. That is nodes 10 and 11 are generated, and by bounty function. Then bounty function means that we'll kill our 10 and 11. So now we are left with 6. So the child of 6 is the child of node 6. The child of node 6 now is 12, and it satisfies the condition of the problem, which is our answer node. So what's our optimal path? As you can see, it's 1, 2, 2, 6, 6, 12. So we have the not the least, that is a Lifo method, that's the last in, first out. So this is a diagram here. So the data structure that we'll use here is a sort data structure which is empty, assume empty, and same our answer is 12. Our answer there is 12. So now this is how it's been arranged. So it's last in. The last element is 4, followed by 2, and followed by 2. So these 2 now will leave because we are talking about last in, first out. The 2 go. So we need to delay 2. So we'll repeat this process and again. So when you delay 2, what will come in? The children of 2, which are 4 and 5, 5 and 6. 6 now will enter first before 5, and then we need to delay 5. So we'll repeat this process as in that of Q. So this is our optimal path obtained with first in, first out search. 1, 2, and you can see. So let's move on now to the least cost.
This course, a both Fifo and Lifo branch and borrow the selection rules for the next inert in rigid and blind. The selection rule for the next inert does not give any preference to a node that has a very good chance of getting the search to an answer node quickly. In this node, we will use ranking function or cost function to generate the children of E node among these live nodes. We select a node which has minimum cost. By using ranking function, we will calculate the cost of each node. So, for example, we will take this diagram and explain it. This diagram physically is different with the 2 last one because here we have the cost every node. So to solve a problem using this diagram, please, using this diagram, first, you are supposed to follow the smallest cost for each inert children. So, for an acceleration, take 1 here, exponential for the inert. Children of the inert are 2, 3, and 4. 2 have 2 as score, 3 has 3, and 4 has 4. So 2, 3, and 4 is not our answer because our answer is 12. So we select the smallest score. Smallest score here is 2. 2 is for 2 nodes. So we want to expand 2 nodes. The children of 2 nodes are 5 and 6. 5 have 4 as score and 6 have 1. 1 is the smallest one. So we want to take 6 as our E node for instance. At that time, please. So I expand 6 nodes. 6 nodes have as children 12 and 13. 13 have 5 as score and 12 have 1. We want to continue with 12 or 12 is our target. So we want to terminate our procedure there. So 12 is our answer. We want to remove back to the parent node to give the cheapest path. The cheapest path now are 2, 1, pardon, please. 1. From 1 to 2, from 2 to 6, and from 6 to 12. That is our answer using least cost algorithm.
Okay, thank you very much. This we have come to the end of our presentation. Please obviously stay focused and learn. So these steps are very easy and applicable. So thank you very much for your kind attention. And
I'm very sorry for my language because English is not so easy for me. Thank you.
thank you. Bye bye.